Sam. I hope you all are doing well. And today's video is going to be about working with the solution pool in IBM ILOG CPLEX Optimization Studio. So let's get right into the video. Sometimes good feasible solutions are more attractive than the optimal solution. Or a decision maker might want to examine alternate optimal solutions. In this case, having a solution pool that includes multiple optimal and feasible solutions is very useful. The good news is that OPL supports the CPLEX Solution Pool feature for mixed integer programming or MIP models. The solution pool is a way of generating and keeping more than one solution to a MIP problem. This allows you to evaluate and explore alternative solutions. For example, you might prefer a solution which also meets a secondary objective over the incumbent. By watching this video, you will learn about the default pool of feasible solutions, obtaining more non-optimal solutions, setting some solution pool options, and filtering the solution pool through a facility location example. A company is considering a few locations to build warehouses to supply its existing stores. Each possible warehouse has a fixed maintenance cost and a maximum capacity, specifying how many stores it can support. Each store can be supplied by only one warehouse, and the supply cost to the store differs according to the warehouse selected. The application consists of choosing which warehouses to build and which of them should supply the various stores in order to minimize the total cost. Here is the CPLEX project of the facility location example. This project includes 4 different run configurations, multiple model files, multiple setting files, and multiple data files. So let's start with the basic configuration, which includes one model file and one data file. So let's execute the basic configuration. So it takes a few seconds for CPLEX to solve this mathematical model. After we execute the run configuration of this mixed integer programming problem, the information on the solutions found is displayed. The statistics tab actually displays the number of the solutions in the pool. So here we have a solution pool and it shows the count and the mean objective. Count means the number of the solutions found by CPLEX, which is 5. So there are 5 solutions in the solution pool. And mean objective is the mean of the objective function value of all of these 5 feasible solutions. And also we have the Solutions tab. The Solutions tab displays the optimal solution. If there are pool solutions in the problem browser, by clicking a pool solution, you display the details of the intermediate feasible solution in the Solution tab. The solutions in the pool are identified by an index number starting from 0, as you can see here. Generally, the lowest index numbers are for the solutions found earliest. The index numbers may change after repopulating the pool, depending on the strategy in use when the pool reaches its size limit. When we select a solution from the list in the problem browser, the values are displayed in the Solutions tab. So, for example, if we select solution pool number 1, in the Solutions tab, we can see the solution number 1. Or in another example, if we select the pool solution number 2 in the problem browser window, in the Solutions tab, both solution number 1 and number 2 will be displayed. And as you can see here, we have solution pool number 2, and also we have solution pool number 1. By default, the pool collects the feasible solutions, if any. That is, all the solutions that work out at the cost of not satisfying the objective by a certain gap. You can use option settings to collect more of these non-optimal solutions. If you realize that you need additional solutions after solving your model with CPLEX, you can set the IDE to show more of them by activating the Populate Solution Pool option. The number of the solutions you see depends on the values you select for the associated MIP or solution pool options. These options set CPLEX to spend some extra time after the search to find more feasible solutions by using some specific strategy. So I want to use the scalable data run configuration, which includes one model file, to show you this feature of CPLEX. To obtain more solutions, first we should create a new settings file. So I right-click on the run configuration and I click on new settings. So one new window pops up. You should select a name for the popped up setting file. I select pool as the name and I finish. When I create this new setting file, you can see the new setting file here, pool.ops. So I need to add this setting to my run configuration. I'm going to use the scalable data run configuration. So I drag and drop this setting file to the scalable data run configuration. And as you can see, this new setting file is added to the pool, to the scalable data configuration. I click on the setting file. Here you can see the setting file. Under the mixed integer programming, we have option solution pool. So I click on the solution pool under the mixed integer programming, and we have an option, populate solution pool. You should check this option. Let's run a scalable data configuration when the populate solution pool is inactivated to see the difference. So I inactivate this option and then run the scalable data run configuration by right-click on this and then selecting run this. So it takes a few seconds for CPLEX to find the solution. Here we go. So let's go to the statistics tab to see the size of this pool of the solution. So here the count of the solution pool is 2, meaning that there are only 2 solutions in the solution pool. So let's activate this option and save the setting file. And again, I want to run the scalable data configuration with the modify setting file. So again, I right-click on this and run. Again, we should be waiting for a few seconds. Here we go, we got the solution. So let's take a look at the statistics tab. So here, as you can see, the count of the solution pool is now 23. So when we activated the populate solution in the setting file, we can see that the number of the solutions in the solution pool has increased to 23. But in the default setting, CPLEX could only find 2 solutions in the solution pool. By activating that option, we could find 21 more solutions. So now we have a larger pool of feasible solutions. When you activate the populate solution pool option, you can use the other options here to change the gap tolerance, the number of the solutions stored, and the criteria on which solutions are substituted for others when the solution has reached its maximal capacity. For example, here we can limit the number of the solutions kept in the pool. The default value is a very large number. So if I choose a smaller number like 14 and save this file, and I want to run it, this configuration again. So let's see what changes. Again, we should go to the statistics tabs. As you can see now, the count of the solution pool is 14 because I've set a cap on the number of the solutions that can be stored in the pool of the solutions. So let's check out other options. So here we have solution pool replacement strategy. we have three different strategies. So, for example, replace the first solution by the most recent solution, first in, first out. This is the default setting, but you can choose another setting. For example, replace the first solution which has the worst objective. So what this means, what the replacement strategy means, it means that when CPLEX reaches to the maximum size of the solution pool, which is 14 here, if it finds more solutions, it replaces the new solutions with the existing solutions in the solution pool based on these strategies. So, for example, if you select the third one and CPLEX reaches to the maximum capacity of the solution pool, it replaces solutions in order to build a set of diverse solutions. Or if the second option is selected, it replaces the new solution with the first solution which has the worst objective. You can use IBM script statements to filter out solutions from the pool. If, for example, you are not satisfied with the solutions yielded by the scalable data configuration with the solution pool options you set, you may decide to go further and create arrays of variables and coefficients to add range or diversity filters. Typically, there are two kinds of filters for the solution pool. The first type of the filter is diversity filters, and the second type of the filters is range filters. Diversity filters allow you to generate solutions that are similar to or different from a set of reference values that you specify for a set of binary variables. And range filters allow you to generate solutions that obey a new constraint specified as a linear expression within a range. So here I want to use the filter script run configuration right here to show you an example about range filters. This run configuration includes only one model file, as you can see here, that includes an execute block. And in this execute block, I have added a range filter. So a range filter adds a constraint over a linear expression. You add a range filter if, for example, you have used the solution pool to get many solutions, but you are interested only in the solutions where the number of open warehouses in the facility location example is between 30 to 43. So when we ran the scalable data run configuration, we got a pool of solutions, and we used populate option to get even more solutions. But we didn't care about the number of the open warehouses in the solutions. Here, we want to limit our solutions to only the solutions that have only 30 to 43 warehouses. For this purpose, we first define a list whose size is the total number of the warehouses, and we assign value 1 to all elements of this list. And then open is our binary decision variables. It's 1 if a warehouse is open and 0 otherwise. So we use CPLEX.addRangeFilter. So addRangeFilter is a method for CPLEX class here. So the minimum number of the one values should be 30, and the maximum value should be 43. Then we write the name of the binary decision variable, and then we write the name of the list that we have already defined. So this function or method means that the total number of the elements of open decision variables that are equal to the associated elements of the coefficient list should be between 30 to 43, meaning that at least 30 warehouses should have value 1 for their decision variable, and at most 43 of the total warehouses should have value 1 for their binary decision variable. So when we right-click on the filter script run configuration. It takes a few seconds to get the solution. So here we go, we got the solution. So let's check out the statistics first. So here we have only 4 solutions, but in these 4 solutions, the number of the open warehouses is between the range that we have already defined in the model 5, between 30 to 43. So by adding this range filter, we decrease the total number of warehouses from 23 to 4. And all of these solutions satisfy the total number of open warehouses for open decision variables. So when you count the number of 1 values in this list, it should be between 30 to 43 for all of the solutions.